A software team in a bustling office in Bangalore once built an AI tool to predict customer churn. But they never stopped to ask what would happen if the AI started identifying loyal customers as likely to leave just because they were browsing the site at odd hours. The AI started aggressively sending discount coupons to people who didn't need them, costing the company a fortune in wasted marketing budgets and eroding their premium brand image. This is why we start with risk identification. In the world of ISO/IEC 42001, risk identification is the process of finding, recognizing, and describing risks. In simple terms, it is the art of asking what could go wrong before you ever write a single line of code. You are essentially playing the role of a detective, looking for the cracks in the sidewalk before anyone trips. If you wait for the AI to make a mistake in the real world, you are already too late. You are reacting instead of preventing. Many teams get caught in the everything is fine trap until a major failure forces them to pay attention. By identifying these risks early, we move from being surprised by failures to having a clear, actionable roadmap of potential hazards. So, now that we've mastered the art of playing detective to spot potential trouble, you might be wondering how we structure this investigation so we don't just guess at what might happen. Well, that brings us right into our next step, which is brainstorming and expert judgment. Imagine a retail giant in Mumbai gathering their developers, customer support staff, and legal experts in one room to talk about an upcoming AI-driven inventory system. The developer worries about server crashes, the support staff worries about incorrect order confirmations, and the legal expert worries about data privacy laws. This is what we call expert judgment. The standard encourages us to use the collective knowledge of the organization to identify risks. In simple terms, it means getting the right people in the room to share their nightmare scenarios. You've probably seen this at the office where one person thinks a project is safe, but another person points out a massive blind spot they never considered. When we identify risks, we aren't looking for one person's opinion. We are looking for the cumulative wisdom of the team. If you only listen to the engineers, you'll miss the legal risks. If you only listen to the legal team, you might miss the technical bottlenecks. This is where we combine diverse perspectives to create a comprehensive risk map that covers every corner of the project. By forcing these different departments to talk, we uncover hidden dependencies that would otherwise cause a project to collapse. So now that we have mastered using the collective wisdom of our teams to identify potential pitfalls, you might be wondering how we can use past data to predict future failures. Well, that brings us right into our next step, which is the historical data analysis technique. A logistics firm in Chennai recently had their AI-powered delivery system fail because they didn't account for extreme weather patterns that had historically caused road closures every 3 years. They had the data sitting in their old archive files, but they didn't think to cross-reference it before training their new model. This is the importance of historical data analysis in risk identification. It means looking back at past incidents, near misses, and even minor system glitches to predict what might happen next. Think of it as studying for an exam by looking at previous year's question papers. The patterns repeat themselves if you know where to look. In our audit process, we look for evidence that the organization is checking their logs, incident reports, and past project reviews to find recurring themes. If an AI project had a data privacy leak last year, that isn't just a past event. It is a critical risk factor for every future project that handles sensitive information. We aren't just guessing. We are using the company's own history to build a shield against the future. The most successful organizations are the ones that treat every past failure as a lesson learned rather than a secret to be buried. So, now that we've mastered how to use the company's history to predict upcoming risks, you might be wondering how we look at the specific way the AI itself is built to find internal weaknesses. Well, that brings us right into our next step, which is scenario analysis. Consider an e-commerce platform in Delhi that is testing a new AI chatbot. To be sure it's ready, they run a simulation where they feed the bot aggressive, impolite, and confusing user inputs to see how it responds. This is scenario analysis, where we create what-if situations to test the AI's limits. It is a way to identify risks by actively trying to break your own system in a safe space. It's not about being negative, it's about being thorough. You've probably seen this where a team assumes the user will always follow the instructions, but in reality, users do the exact opposite. By creating specific scenarios like what if the AI loses internet access or what if the input data is suddenly corrupted, we force the risk to the surface before it can surprise us in the real world. It's like a pilot in a flight simulator dealing with an engine failure. You want to experience the crisis in a controlled environment so you can learn exactly how to handle it when things really count. This practice transforms potential disasters into manageable operational procedures. So now that we've mastered the art of creating controlled scenarios to uncover hidden vulnerabilities, you might be wondering how we look at the system from the outside in to find environmental risks. Well, that brings us right into our next step, which is a SWOT analysis for AI. A fintech startup in Kolkata sits down to look at their AI-driven loan approval tool and performs a formal SWOT analysis: strengths, weaknesses, opportunities, and threats. They identify that while their algorithm is incredibly fast, a clear strength, they are heavily dependent on a single third-party data provider, which is a significant weakness and a strategic threat. This is a technique used to identify risks by looking at both the internal and external environment. In simple words, it is a high-level check. What are we doing well? Where are we falling behind? What new tech could replace us? And what external regulations might shut us down? You have probably seen projects fail because the team was so focused on their internal code that they didn't notice a new government regulation being passed across the country. SWOT forces you to lift your head up and look at the horizon. It helps you identify risks that don't come from the software itself, but from the changing business and regulatory landscape around it. It ensures that you aren't just building a great tool, but a tool that can survive in the real world. So, now that we have mastered how to look at the big picture and identify strategic threats, you might be wondering how we make sure we haven't missed any of these identified risks during the crunch time of a project. Well, that brings us right into our next step, which is the register of risks. To finish our journey, consider a major corporation in Pune that manages hundreds of AI models simultaneously. They don't rely on anyone's memory. They maintain a master risk register. This is the ultimate document where every identified risk, whether found through brainstorming, data analysis, or scenarios, is captured, described, and tracked. Think of this as the final ledger for our detective work. If a risk is identified but never written down in the register, it simply does not exist for the auditors. The register must be a living, breathing document. It is not enough to identify a risk and then file it away. You must assign it an owner, a current status, and a detailed plan for how you are monitoring it. When you finally sit in that audit chair, your professional credibility comes from your ability to pull up this register and say, here is the comprehensive list of everything that could go wrong, and here is exactly how we are watching it. You have moved from the theory of identification to the practical daily task of proving you have a grip on the uncertainty. You are no longer just building AI, you are managing the future with confidence, diligence, and a clear, unwavering record of your commitment to organizational safety.